Hi, so today's video we're going to talk about sequences, and sequences basically can occur anywhere you like. Anywhere you can see some kind of pattern, then you've got a sequence. If you've got a rule that you can apply to that, then you can describe it as a sequence. So I've got some sequences on the board just to go through, and all we're going to do in today's video is just basically look at if we can recognise what's happening in the sequence. We can determine what's going to happen next following the same pattern, and then come up with what that rule is. Now importantly, if you have a look here, I've put find the next two terms, and I've also said find the term to term rule. Now what I mean by term, first of all, each of these items in the sequence is called the term. Okay, now I say item instead of number because it doesn't have to be a number, and if you have a look at the third example I've got here, I've actually used letters, and in a minute I'm going to show you some sequences from patterns, which is why I was saying to you, you know, you can find them in lots of different places, not just in the maths classroom. So these are different terms. So what I mean by term to term rule is how do I get from one term to the next term. So what's the rule that gets me from one term to the next term? Now there's two different types of rules that we can work out. This is the one that we're doing today. There is another rule that we call the nth term, and that uses a bit more algebra, and that means we can come up with a formula so we can find any term in the sequence. But today we're just going to focus on what's the rule, how do we get the next term along, and how can we write down what the rule is. So if we look at the first one, we've got 2, then 5, then 8, then 11. Whenever you're looking at a sequence, you've always got to look at, okay, what's happening? Can you see something that's happening every single time? Can you spot what the pattern is? And sometimes it'll be easier, and sometimes it's a bit more difficult, okay? So in this one, if we look, hopefully you can see, and I'm just going to draw these little lines underneath so we can kind of make the link between each term. When we go from 2 to 5, we add 3. So I'm going to put here, add 3. When we go from 5 to 8, we add 3. When we go from 8 to 11, we add 3. And it's always a good place to start just by adding or taking away something, because it's nice and simple. And if you see the same things happening every time, then that must be what your rule is. So it's pretty safe to say that that must also be happening here and here. Now if we add 3 to 11, we get 14. And if we add 3 to 14, we get 17. So that helps us with the next two terms. The term to term rule then, we can just write it in words, is quite simply to add 3. That's all we're doing. To go from one to the next, we're just adding 3, okay? Right, second one here, we've got 15 going to 11, 11 to 7, and 7 to 3. So we can look at that and see what's happening. Now this time I think it's fairly obvious we're not adding anything because the numbers are getting smaller. So the next simplest thing to look at is maybe we're subtracting instead. So to go from 15 to 11, we're taking away 4. And to go from 11 down to 7, we also take away 4. And to go from 7 to 3, we also take away 4. So again, we've got that repeated pattern, so it seems to be that that is our sequence. So if we take away 4 from 3, we actually go into negative numbers. So if you think about your number line, okay, we're at 3, and we want to take away 4, so we go down 4, it goes below 0, all right? So it only goes 1 below, so therefore our answer is -1. Now we're at -1, we've then got to take away another 4, okay? And as you know, when you go past 0, the numbers go -1, -2, -3, -4, so it seems like they're getting bigger, but the bigger the number actually is as a negative number, the smaller it is in reality, because you're going down. So if we're doing -1 and then taking away another 4, we actually get to -5. Alright, you can count it down. So if you're at -1 and you go down 4, got -2, -3, -4, -5. Okay, so that is the next two terms. And then the rule is, well, in this one it was just add 3, in this one it's subtract 4. Okay, now just to illustrate to you that that sequences don't have to just be about numbers, I've put this sequence here in. So we've got J, F, M, A. So this is a good one for your lateral thinking. Can you come up with what that might be? Do you recognise those letters? Do they appear in anything that you see around you? Okay, and something that we're in at any particular time. And the answer is that they're actually the months of the year. January, February, March, April, and it's just the first letter of the months of the year. So as I said, it doesn't matter, it doesn't have to be a numerical value. This is a sequence, it's the months of the year, it's the first letter, it counts as a sequence, and so therefore as long as we know what the pattern is, we can describe what the next letter is. So January, February, March, April, May, June. And what's the term to term rule? The term to term rule would be that it's the next month of the year. And if you want to be really specific, you can say the first letter. Okay, right, the last one, again I've given you one that's a little bit more tricky to get you thinking about it. So what's happening here? 1, 4, 9, 16. So we can start to think about it in the same way we did up here. Okay, so do we spot a pattern there? And I think you could probably see quite quickly that we're not going to have that same kind of pattern straight away, but it's still worth possibly looking at what happens exactly. So if we go from 1 to 4, we add 3. If we go from 4 to 9, we add 5. If we go from 9 to 16, we add 7. Now there might not be a pattern here directly, but look at these numbers, 3, 5, 7. They're actually the odd numbers. There's a difference of 2 between each of those. So possibly the next one then, if we're following that same pattern, 3, 5, 7, the next number would be 9. So we could say we're going to add 9. And if we do the same again, 3, 5, 7, 9, we'd add 11. So there is a pattern, it's just a little bit more tricky to spot. So if we add 9 to 16, we get 25. And if we add 11 to 25, we get 36. Now some of those amongst you who might be a little bit more eagle-eyed may be able to spot another thing about this sequence. Now that is that these are actually the square numbers. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and 6 squared is 36. Now that would actually count as being the nth term, but the term to term rule for this one, what we would actually say is we are going to add the next odd number. So that would be your term to term rule for that particular sequence. Now there's one other sequence I would really like to show you before we look at patterns, and that is this one. So just give myself a little bit of room here. So the sequence I'm going to show you is this. See if any of you recognise it. Okay. Now This sequence is a very famous sequence, and this sequence is called the Fibonacci sequence. Okay. Now, some of you may know what this is about, others of you may not. See if you can spot the pattern. So it may look, first of all, like, okay, well, there's not, you know, what's going on. The difference between these two is 0, then we have a difference of 1, then we have a difference of 1 again, then here we have a difference of 2, and then here we have a difference of 3, and so on, and it changes, and this one actually is a difference of 5. So what's going on? But actually what happens with the Fibonacci sequence, to get the next term you need to add together the two previous terms. So if we start with 1 plus, there's no other term, so it's 1 plus 1, 1 plus 0 rather is 1 again. Then we have 1 plus 1 gives us 2, 1 plus 2 gives us 3, 2 plus 3 gives us 5, 3 plus 5 is 8, 5 plus 8 is 13, and so on. So you need to know the two previous terms to get the next term of the sequence. Okay, they're very heavily reliant. Now, I would encourage you to have a little look at the Fibonacci sequence, because it's got lots and lots of interesting facts about it, because it appears in nature, in architecture, in drawings, in paintings. These numbers are quite special. Okay, so I'd encourage you to have a little look at those. And actually, what you can also do, if you start to produce a pattern, so if you divide the numbers of the Fibonacci sequence, they tend towards a particular number, and that particular number is called the golden ratio. And that ratio appears in nature. It appears in the ratio between different parts of our bodies, with animals, with different parts of nature, for example snail shells, if you look at pine cones, pineapples, all sorts of things like that. So it's a really interesting thing to look into, and it just goes to show you that sequences can appear in lots of different places, not just in the maths classroom. Now, I promised you we'd also look at some patterns today, so just turn the board over. So I've got some sequence patterns for you on the other side. So again, just to show you a different way that sequences can appear. So can you draw the next pattern, and what is the rule? Okay, so I've given you this one here to begin with, and actually this is quite an interesting one again. So here we've got 1 dot, and then we've got 1 dot with 2 underneath, and then the one with 2 we've added a row of 3, and so on. So what actually happens is you start to form a triangle, and these actually produce the triangular numbers. So the next pattern, we'd have to draw the previous pattern and add another row, and in that new row we have to have 1 more dot. So the next row has got to have 4 dots. Okay, now if you look at the numbers of them, here we've only got 1 dot, here we've got 3, here we've got 1, 2, 3, 4, 5, 6. In this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we already know the term to term rule because it happens from the sequence itself. So like I said, we're adding another row each time, and when we add that new row we've got 1 extra dot. So to go from here to here, for example, we are adding 2. To go from here to here we're adding 3. And here to here we're adding 4, and so on. Alright, so basically for this one we're adding 1 more each time. Now, sequences are lovely things to do investigations with, particularly when we've got patterns, because you can look at all sorts of different things in the way they appear. So I thought I'd show you this one as well, just to show you something else a bit more interesting. So here I've got 1 square, then 2 squares, then 3 squares, and we've got some red dots around them. Now you might think, well, how is that going to be a sequence? Well, for a start you could draw the next pattern. So you'd have to have, or we could draw it quickly, you'd have to have 4 squares. So do excuse my pitiful drawings, you'd have to have 4 squares and then your dots. I'll just very quickly put those on. But what do we notice about it? What's the rule? Well, maybe we need to think about breaking it down. So we could think about the dots. So how many dots are there? So if we label these up as patterns number 1, 2 and 3, if we just look at the first 3. So for pattern number 1 we had 4 dots. For number 2 we've got the original 4 plus another 2, so that's 6 dots. And for the third one we've got the 6 plus another 2, so we've got 8. So for the red dots you can see we're adding 2 each time. Let's have a look at the black lines then, and again we'll just look at the first 3 patterns. So on the first one we have 4 lines, we've got the square, 4 lines. On the second one you've got 2 squares, so you'd think there would be 8, but this one is shared. So you've got your original 4 plus 1, 2, 3, so it's 4, 5, 6, 7 lines. And then on the third one we know there are 7 up to there, and again we're adding on another 3 here, so 7, 8, 9, 10. Now obviously in your own time you can take a bit of time over this and look at it in more detail and possibly draw out the shapes yourself so you can see what's happening. So here what's happening is we're adding 3. And what I think is really exciting about it is by drawing it out as a pattern you actually get to see physically, well, what is happening each time, what is it that we're adding on. So hopefully if you start to build things up like that you can start to think about, okay, well what would the pattern look like if I had say 10 squares in a row or 20 squares in a row? What would happen if I had the 15th row in your triangular numbers, and so on. So I will do another video where we look at finding this algebraically as well, looking at the nth rule, the nth term, but for the time being we're just looking at here how to find the term-to-term rule. So getting as far as this is absolutely fine, and starting to investigate the patterns and what happens and generating the rule really helps before you then move on to the algebra. So I hope you found that interesting and enjoy having fun with sequences.